So we're going to go ahead and continue our reverse engineering of the Casio PT180. This time looking at the top board, what we're calling the user interface board. And this particular board has 19 lines that we've decided to focus on. And in continuing with what we did last time with the keyboard switches, we're going to look at the switches on the user interface board and map those out. So, I believe going from this side here, that's going to be the stop button. So,
this one.
Yep. So why don't we get the top of the stop button and see what that connects to.
So diode up here.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Okay.
And the bottom of that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Huh.
Try again.
Oh, 2.
2.
That solder blob is not particularly conductive.
Okay. And then now the next switch, rhythm select.
Okay. Diode. Is that 11?
Yep, looks like it. Okay, and then the bottom of that one.
Pin 1.
Okay. Next one is tempo down, actually.
$11 for the top. $3 for the bottom.
Okay. Next one is tempo up.
$10 for the top. $3 for the bottom.
Okay. And then on that other side of the board, we've got 2 switches. One is key play left, and the other is key play right. So.
Okay, these look like they might be rotated a bit, so the bottoms might actually be the tops, diode-wise. Yep.
Okay.
So the bottoms of these switches are the tops of all the other ones we've done.
Okay.
So go through here, diode, 10 for the top of that.
Okay.
$13 for the bottom of that. And then the top of the next one. I'm seeing over here. There's its diode. 11.
Okay.
And the bottom looks like the same as the previous one.
Probably.
$13.
Okay. All right. So those are the switches that we can obviously tell on the top. The next thing I wanted to check out through the magic of prepared pages is the shared lines between the keyboard and the user interface board.
Ah, yes, because the CPU is obviously only has so many I/O pins, and some of them are going to be assigned to doing the scanning of this matrix. Naturally, some of the lines that hit the matrix down here on the keyboard part are going to be used here as well for scanning buttons in this. It's not necessarily intuitive unless you've designed one of these circuits, but you're not going to generally create two different matrices. If you've got buttons that you want to watch and buttons that you want to watch, you're just going to put them all in one matrix and then figure it out in software.
So on my setup, or my sheet I have set up here, the user interface lines across the top, so that's 1 through 19, and then the keyboard lines, which are 1 through 13. And we're just going to use the multimeter again to beep out what's connected to what.
So up here it's 1 through 19, and down here it's 1 through 13.
Right.
How do you want to approach this?
Let's do 1 through 19 as the stable, and then run through the 13 on the bottom. Does that work?
Mathematically, it's more efficient to do 1 through 13 because there's less of them.
All right.
As the one we stay on.
Sure. Go for it.
Okay, so pin 1, see if it exists. It does.
Ooh.
1, 2, 3, 4, 5, 6, 7, 8, 7. Yep.
Okay.
2. Does exist. 1, 2, 3, 4, 5, 6.
Okay.
3. 8.
8.
Pin 4. 9.
Oh, I have a question. Are we going? Now I'm lost. You're going on from the keyboard. So on pin 1, that's connected to 7. Oh, I see. Okay. All right, continue. 2, 6. Know where you're coming from and where you're going to, folks.
Right.
That helps.
Give me a second to
Okay.
remap there.
All right. I got it.
Okay, so 5 on the keyboard goes to 5 on the user control board.
Okay. Do we get 4?
I did.
Oh, sorry. I missed that one.
Nine.
Okay. All right. Sorry. Now I can go to
6.
6. Yep.
4.
Okay. 7.
Not getting any beeps.
Okay. And then 8.
Pin 1. 3,
Okay, 10,
2,
11,
13,
okay, 12,
no beeps,
okay, and then 13.
12.
Okay. Okay. So we've got the switches on the top somewhat mapped, and we've got what lines are shared between the keyboard and the user interface boards.
And we noticed that not all of the lines down here at the keyboard are connected at this point here. So when we go to hijack these switches with our NPN8s, we can't just steal all the lines from this point. We would have to get them from here, where this one connects here, or somewhere up in here around the CPU. But we haven't gotten to that point yet. We'll have to trace up a little bit further yet. So come back for that, because that's where we're heading.
Onward and upward.
Protosynth MIDI, Protosynth MIDI Lite, and all compatible modules are available for sale at tindy.com/stores/TYMKRS, and in-depth technical information about this and all of our products are available at tymkrs.com.